Hi, this is the first of two lectures for the Introduction to the Periodic Table. I split this up into two different lectures. Let's get started. Let me start off by really quickly giving you a little bit of a helpful hint. Anytime I write the word remember in your notes, that means that this information is coming from a previous lecture that I've given, so a previous chapter. And that means that for you, that you need to know this information for this upcoming quiz or test. In chemistry, there's a lot of building upon what you know, so it's not like you can just take a quiz or a test and then forget it. So I'm trying to help you, give you some hints to, oh, you need to go back and remember this, or if you didn't learn it the first time, go back and learn this, because you're going to need to know it in order to continue on. In this case, let's start with matter is anything that has mass and takes up space. We learned that in the past, like I just said. But why do we need to know that? Well, chemistry is the study of matter and the changes that it undergoes. We're still studying matter, and as soon as we finish studying matter, we'll start studying the changes that, that matter undergoes, and we'll be doing chemistry. But what is it about matter that makes, that gives it the mass and the volume? It's the elements. All matter is made up of roughly 100 different elements, and it's a badly written sentence. Actually, there are roughly 100 different elements that make up all matter. They combine differently to create all matter. Matter could just be one single element. Boop, boop, there it is. I'll give you some examples here in just a second. Matter can be made of a combination of two or more different elements. That's a compound. And but most of the things that you interact with, yourself, are mixtures of many different compounds and elements. So remember that compounds are made up of elements that are chemically combined. So there it is again, that's a compound. And mixtures are made up of compounds and elements that are together. They hang out together, but they're not chemically combined. Remember, a homogeneous mixture is one where you can't really tell that it's a mixture, but it is. And a heterogeneous is where you can look at it and say, oh, that's obviously a mixture. So because you can see the individual pieces. Here's an example of matter that is made up of just one element. We run into elements all the time. It's simple. It means that all the atoms in there are the same. They all have the exact same number of protons. And in this case, I'm just showing you an example of titanium. If you want to know all the elements, you go to the periodic table of elements. We have 118 of them right now. Remember, elements are pure substances. Another type of pure substance is the compound, or a compound. This is matter that's made up of two elements, specifically here. It could be more, and that's the next example. A matter that is made up of two elements, the big example is water, H2O, hydrogen and oxygen. And the other big example is NaCl, table salt. I use those both in class all the time. Not just to eat, but also as examples in chemistry. Here's an example of matter that is made up of more than two elements. It is also a compound. Remember, compounds are pure substances, and they're not mixtures. An element and a compound, those are both pure substances. This one, it just happens to be made up of more than two elements. C7H5NO2. How many different elements is that? There's 1, 2, 3, 4. How can you tell? You can tell how many different elements something is made up of by counting the uppercase letters. If you have a capital letter, that's a brand new element. If it's a lowercase letter, that's not a brand new element. It just goes with the uppercase letter next to it. So, so that's how you can do it. Count. Every time you see an uppercase letter, you're dealing with a brand new element. In this case, my example of that white powder right there is sodium benzoate, or that's what they tell me that white powder is. It's sodium benzoate. It's an extremely common preservative that you see in a lot of foods. So next time you're drinking something out of a can, eating something out of a box or a carton or anything like that from the store, take a look on the ingredients and see if it has sodium benzoate. If it does, now you know what it is. It's C7H5NO2. And like I said earlier, the majority of things that you run into, and I run into, that we all run into, are mixtures. Mixtures of compounds and elements. So they're not chemically combined together, but they just all kind of hang out together. Here's my soda that I had that morning, and there's that sodium benzoate I'm pointing at. And you can see that it has carbonated water. That's a mixture in and of itself. Water is a compound. The carbonation, CO2, is a compound, but the carbonated water, they're mixed together. Citric acid is what gives it the lemony flavor. That's in a lot of foods. That is also a compound. Aspartame is the sweetener, compound. Sodium benzoate is the preservative, compound. Those are all mixed together, and there's a bunch of other ingredients in there, colorings and things like that, that are compounds. I didn't see a single element by itself, but all those compounds are mixed together to create the soda that we drink. Here's the definition of element. The actual definition is a pure substance that cannot be separated into simpler substances by physical or chemical means. That's the definition you need to know. And if you go any smaller than an element, you're looking at it on the atomic level, and so we're not doing that yet. So element is the fundamental piece of matter until, of course, we go into the atom. On Earth, we have 91 elements that naturally occur. Everything else is man-made. Here's the periodic table of elements. They're all over my room in class, so you should be familiar with what this looks like. The definition is it's a table that organizes the elements into a grid of rows and columns. The periodic table of elements is really, really kind of neat, because the more in-depth you go into it, the more you look at it, the more you find how well organized it is and how useful it is, how much information it can give you. So it's pretty cool. And I know that you guys have studied a little bit of this back in the 8th grade, and we're going to go way in-depth into it a little bit later. If you ever run into a time where you're needing to do homework and you don't have a periodic table handy, go to ptable.com. Oh, I can't write. There we go. Go to ptable.com right there. That's where I got this. It's an interactive periodic table. Really, really great place to go. So you never have that excuse, I couldn't do my work, because as long as you have the internet, you got the ptable.com. And like I said, this is just an introduction, so this is stuff that you probably already know. Every single element has its own name that's unique to itself. We call it the chemical name. That's the official word. Every element has its own symbol that's unique to it, and we call that the chemical symbol. That's the official name for it. All symbols contain either one or two letters. Don't fight me on that. I'll explain a little bit later. But all symbols contain one or two letters. The first letter is always uppercase, capital letter. If there are any other letters that follow that first one, they are always lowercase. Don't ever get those wrong, because you're not speaking correctly. It's gibberish, and I will count it wrong on a quiz or a test. I'm mean about that. Every element has its own place on the periodic table, and it has its own tile on the periodic table. Each tile, every periodic table will show the atom's chemical symbol, and it will show the atomic number. Those are the two things that we need in order to, have a good periodic table. The symbol we already spoke about, and the atomic number is, in case you get confused, it's the whole number up at usually it's at the top. No decimal place, atomic number. That is how we identify the element. So we don't identify the element by its name. We don't identify the element by its symbol. We identify it by its atomic number. That's how we know that chlorine is chlorine. It's not because it's named chlorine. I'm not Miss Thompson because I'm named Miss Thompson. I'm Miss Thompson because we really don't know why I am. Why we are who we are. Our brains, our souls, our thoughts, whatever. I don't know. Our hearts. But we do know why atoms or why elements are elements. It's because of the number of proteins. Proteins? How about protons they have? It's the number of protons they have. And chlorine is chlorine because it has 17 protons. What if it didn't have 17 protons? It wouldn't be chlorine. It'd be something else. Here I'm just showing you that the atomic number is that little doober right there, and the chemical symbol is that guy right there. In addition to the atomic the chemical symbol and the atomic number, most periodic tables will show the chemical's name and the average atomic mass. The chemical name, a lot of people want to know how does an element get its name? It takes quite a while for it to happen, because usually there's a lot of fighting between scientists over, what to name the elements. And there's some pretty cool stories about how some of the elements got their names. Ask me in class. I'll share a few with you that I know of, and I'll share some books with you where you can learn them and tell me some stories. But ultimately, who has the power? IUPAC. And that's the organization of chemists who get together, and they set all the standards for chemistry. How do we name the chemicals? How do we name, what's the name? How do we spell the name of the elements? What's the symbol? All of that is determined by IUPAC. And it's an organization where they just, I don't know what it looks like. Do they beat each other up, or do they just play rock, paper, scissors? I have no idea. But they come out every now and then and they say, all right, here's how it is. And we say, oh, okay. The average atomic mass is the number on the tile with the decimal place. We're going to learn a lot more about this later, but if you remember, you guys probably know it as just the atomic mass, but if you remember it as the average atomic mass, that will help you remember that it has a decimal place, because, averages very rarely come out as whole numbers. Here I'm just showing you that that little doober right there is the chemical name, and that fella right there is the average atomic mass. So there you have it. Okay, remember earlier I said, every symbol is 1 or 2 letters long, and you probably have looked at a periodic table and you have seen the ones that have 3 letters, and you're like, Miss Thompson, and I said, don't fight me. Go with me. I'll explain it later. Here I am explaining it later. Yeah, you're right. Some of them have 3 letters, but those are the elements that have not actually been named yet. So we put a placeholder in there. Like in some cultures, you don't name a child until they reach a certain age. You call them something else. You call them Piggy or something. That actually happened. My mom knew a person who had a kid for like 6 months. They named they called the little baby Piggy, because they didn't have a name for it yet, the little baby. So we use a placeholder, and that placeholder is the Latin word for the number of protons, the atomic number that element has. And so when the IUPAC comes by and they finally name the element, they give it a 2-letter symbol, and they give it its real name. And here's my example. It's Enuntrium, has not been named yet, right there. And so it's UUT, and because it has 3 letters, we know that that's not its official name. That's just a placeholder. And in Latin, 113 is pronounced Enuntrium. According to me, it's pronounced that way. My favorite element used to be Ununquatium, number 114. And then they went and named it Flerovium and gave it its symbol FL. And I can't say Ununquatium anymore. It was a lot of fun. It's sad. But there you have it. Hey, we reached the end of the first lecture. I'm surprised and happy, and I'm sure you are too. Please come up with 3 questions that you have about the elements or the periodic table. You may have always been wondering, why does it look that way? Or why is that named that way? Or why do those people say it this way and we say it that way? Or be specific, though. You can't just, those are very general, and I will not accept those 3 questions. You be more specific. So come up with 3 questions, write them down, turn them in, and I will know that you have reached the end of the lecture. And also show me your notes. Thank you. Goodbye.